Hi, my name is Oktay. Welcome to today's video about the noble gas compounds. This is a nice picture of the noble gases in a gas discharge tube. At the left, that's helium, and neon, argon, krypton, xenon, and there's a radioactive radon. This is the nucleosynthesis, the origin of the chemical elements, and the noble gases are at the right. You can see helium is a product of the Big Bang fusion. The other noble gases were synthesized later. All noble gases have a full shell of electrons. Helium is the second most abundant element in the universe. Neon is the fifth most abundant. This is a picture of the noble gases in air. Most abundant noble gas in air is argon with 0.93%. And you can isolate the different noble gases by fractional distillation. This important fundamentals in chemistry. That's the first ionization energy. That's the energy that you need to remove one electron from an atom. And you can see in each period the noble gases are at the top. They have the complete shell of electrons. It's a very stable configuration. That's why they have the highest first ionization energy. If you want to make noble gas compounds, there's a known compound oxygen difluoride, OF2. Oxygen is in this diagram here, 2 positions to the left of neon. So if you want to make noble gas compounds, the best reactant is fluorine, with its highest electronegativity of all elements. But which of the noble gases should you choose? And this diagram has the answer. You pick those noble gases that have the same first ionization energy as oxygen or below. It's krypton and xenon. These are some examples of the first noble gas compounds. They were synthesized in 1962. At the top left, that's krypton difluoride. It's with its linear structure. Top right, xenon tetrafluoride. It has a square structure. At the bottom left, that's xenon hexafluoride. It has an octahedron structure. However, it is an irregular octahedron because you have 6 xenon fluorine bonds plus 1 free electron pair at the xenon atom. At the bottom right, that's xenon trioxide. It has a tetrahedron structure. The xenon atom sits in the center of the tetrahedron. The 1 free electron pair of xenon points to one of the corners, and the other 3 corners of the tetrahedron are occupied by the oxygen atom. All these compounds have one thing in common: they are very strong oxidants. This is a work of Jingyu and colleagues from China. They synthesized the compound lithium helide from lithium and helium at 700 gigapascal pressure, at very high pressure. This compound is a superconductor at pressures above 210 gigapascal. However, the critical temperature is just 26 Kelvin. So this means this is not a high temperature superconductor. For that, the critical temperature needs to be above 77 Kelvin or minus 196 degrees Celsius. That's the boiling point of liquid nitrogen. There's another known compound, that's sodium halide. Was also synthesized, and at a pressure of above 113 gigapascal, and this compound is known to be an insulator. In this picture you can see lithium halide as bent structures near the Fermi level. That makes it a superconductor. It's another type of compounds, that's endohedral fullerenes. These are atoms, ions or clusters that are trapped inside the football molecule C60, fullerene. And compound argon in fullerene was synthesized at 650 degrees Celsius and 3000 bar. In these conditions, 1 of 1000 fullerene molecules contains an argon atom inside. There's another way, that's intercalation. That's also possible. Intercalation means the argon atoms don't go inside the fullerene molecules, but stay between the fullerene. They stay in the layer structure of this fullerene molecule. This is a nice picture of the structure of planet Earth. And this, you can see in the center the solid core. There's another work of Elissaios, Stavru, and colleagues. And they looked for the depletion of xenon compared to krypton. And above 200 gigapascal and 2000 Kelvin, xenon makes compounds with iron and nickel. And above 150 gigapascal and 1500 Kelvin, you can make the compound xenon and nickel. And this could be the reason why there's a depletion of xenon. But these scientists think this depletion happens in several steps. This is another compound, that's Argonium, ArH+ molecule cation in the Krypton nebula. This is another compound, helium hydride, HeH+. It's has the same number of electrons too as hydrogen. It was found in the Jewel Bug Nebula, NGC 7027. This helium hydride molecule is special because it was the first molecule in the universe after the Big Bang, which happened 13.8 billion years ago. Right after the Big Bang, the temperature and the pressure and the radiation was still too high to make normal compounds like H2, but not too high to make this special compound helium hydride. That's why this molecule was the first molecule in the universe. And that was today's video about the noble gas compounds. Thank you for watching. Have a nice day. Bye bye.